kind of background in this. So, the NVM SMU, the car is always going to hit the wall. So, the speed limit for a public road is 30 miles an hour. If it's a single track road, it's 60 miles an hour. For dual carriageway, it's 70 miles an hour. You know the speeds which the cars are going to travel at. The guy's travelling down the avenue out there at 30 miles an hour. Okay? Now we want to make sure that the driver is as safe as possible when he hits the lamppost. Okay? So if we want to make sure the driver is as safe as possible, we know that his momentum, what his momentum will be. We know the mass of the car, we know that it starts off at a speed of 30 miles an hour, and we know that it finishes at a speed of 0. We know it's changing momentum. Okay? We know by the design of the car, the crumple zones, etc. How much time will the car be in contact with the object? If the car was made of solid steel that didn't buckle, didn't bend, or made of concrete, then the contact time would be bam. You wouldn't do anything, you would have a really high force, and the driver would experience that force directly through his seatbelt. Break every bone in his body. The seatbelt would just crush you, because it would just be smack. There'd be no time of contact, it would just be a boom. Very, very short time. If the car was made of marshmallow, driving along, the marshmallow would go over the lamppost. The time of contact would be huge, and the force experienced by the driver would be much less. Like what? Like hitting a marshmallow. Okay? You can have the same mass in concrete as you have a marshmallow, and you hit a concrete bit of mass, it's going to be a lot slower than you hit a marshmallow. That's why, if you punch the desk, it's quite sore. If you punch a desk made of foam with the same force, it's not sore. Because your hand doesn't feel the force. Because the time of contact is much greater. You hit the force, you hit the table, then you hit it with a sponge on it. It's not as sore because the time of contact has been lengthened. The time of contact between absorbing into your hand has increased the time of contact. The forces, the change in momentum is the same. Your velocity of your hand before and after is the same, but the time of contact is increased, so the force experienced is less. The safety aspect. Okay? So, what we're saying here is if you increase the time of contact, but have the same change in momentum, the force experienced by the object will be less. So it's safer. Okay? So how, to summarise that a wee bit. So, in a situation where the velocities before and after don't change or don't differ by increasing the time of contact, we reduce the force experienced. So for example, let's take an example of our desk or our hand. That's the hand. With 3 fingers. Okay, you're going to hit that on the desk. The hand starts off with a velocity of whatever. So you have a V equal to, say, 10 meters per second. You have a U equal to, oh no, sorry, final will be 0. It's not V equals 10. U will be 10. Going down a way, U equals 10. V equals 0. Time of contact, T, is very small, so say 0.1 of a second. So it's very small. then the force will be high. Force will be high. So the mass is constant. Force will be high. If you have the same example, this time you have a table, you have a sponge, hitting down here, U equals 10, V equals 0, M equals constant, T equals say 2 seconds. Then the time of contact will be greater. So according to Ft equals mv minus mu, the force will be lower. So it won't be as sore. This will be lower. This will be not as sore.
Some physics terms there.
Very physics terms there. Sore and not as sore.
Is there a unit for that?
Don't. Units for sore and not as sore are measured in as and ouches. Point one of an ouch and an as.
That's the length of ouch. Ouch.
Ouch. Ouch. Shorter ouches mean more pain. Small ouch, it's an inverse scale.
You know what we're doing? Ouch. Ouch. Ouch.
What?
That's up the way it didn't really hurt you, were just annoyed.
Yes.
Ow!
Ow!
Oh.
And I don't know.
Maybe we should make it on the other
Let's
side.
not make it into moans of oh!
Yeah,
Ah!
I'm saying-
This is ouchies and
They
ouchies.
can't see what we're doing. We're not hitting.
They can hear us hitting the desk.
Ow!
Yes. Mind you,
It
the
was so
gutter.
hard.
Thanks very much. David. David may be contacted via Government Academy should he be needing for prosecution.
Everything and nothing to do.
Yeah. So this is all about hitting the desk. If you hit the desk for a short period of time with the same force, then, but with the same change of momentum, you will hurt your hand. If you hit the desk with a sponge underneath it, I have labelled the sponge.
That's what they say.
What's that?
Oh, sponge in the
And a sponge, then the time of contact will go up because it's absorbing your hands, and it won't be sore. That is how crumple zones in cars work. That's how people jumping off buildings in stunts land in boxes rather than whatever. That's how trampolines work.
I thought you had a big mess at work because the ground was back in the Harry Potter film.
Okay, so impulse is all about reducing the force experienced by the object by increasing the time of contact.